Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month, and this is July 2026. Can you believe it? 250 years ago, we were signing the Declaration of Independence. Our country was becoming independent from the mother country, if you will, England. And it's just amazing that we have survived as a country this long, and hopefully for many, many more years to come. So with the Sky This Month, one of the things that we want to do to celebrate the 250-year anniversary of our country is to kind of dovetail that concept with something astronomical. And so you can see we've piloted the idea back in April, and we mentioned some stars for you last month in June, and now continuing 250 light years of America with Belmont High School, New Hampshire Astronomical Club. And we are just thrilled. You can see some of the students involved in the club there. And we're just thrilled to offer this program to you. So what does that all mean, 250 light years of America? Well, the club came up with the idea of the distance of stars typically is measured in parsecs or light years. A parsec is 3.26 light years. And a light year is how long, or I should say the distance light travels in a year. And so traveling 186,282 miles per second, light would travel about 7.5 times around the equator of Earth in 1 second. It travels that fast. Our sun is 93, on average, 93 million miles away, and it takes just 8 minutes and 20 seconds for the light from the sun to reach Earth. The moon, around 250,000 miles away, only 1 second and a quarter for light to reach the moon from Earth, or the light from the moon reaching Earth. Light travels really, really fast. But stars, our closest star is like 4.25 light years away, Proxima Centauri. And so light traveling that fast takes 4.25 years to reach us. Now, tying that information in with the idea of our 250 light years of America, we branched out as a group and tried to identify stars that are 250 light years away. About 250 light years away. And so what does that mean? That means when you go out at night, and we're going to share some examples with you that are great for July. When you go out at night and you look at these stars that we're going to mention, we're going to highlight 3 of them tonight, maybe mention a 4th. But when you look at these stars, the photons that are reaching your eye as you look up left that star when we were declaring our independence. Isn't that crazy? An event that happened 250 years ago, the photons, the light particles, if you will, the quanta, as Einstein referred to them as, left the star and are just now reaching the retinas of your eyes 250 years later. It's crazy, but it's just an awesome concept. And I'm going to be sharing a little bit more about this for our Superstellar Friday at the McCall Shepherd Discovery Center. So if you're catching this early enough in the month, Friday night, July 3rd, I'll be speaking about this concept and illustrating these stars in the Planetarium Theater. And on July 4th, the Independence Day, at 9 o'clock in the evening, I will be on the Morgan White Show, WBZ Talk Radio. That's AM 1030 at 9 o'clock. If you are able to want to tune in there, and we'll be talking for about an hour about this same concept. It's an amazing concept, and our students are just so excited to be able to talk about it. And you can see all across our country, different ideas are being shared. You can see Stay Golden, Washington, D.C., the first in flight, America 250, A Giant Leap, Wave Your Stripes, all commemorating the 250-year anniversary. Different things are going on in each state, and what we're doing here in New Hampshire as part of our celebration is this 250 light years of America. So this first image that you're looking at is July 4th, interestingly enough, at 9:30 at night, July 4th, and I thought it would be good to present this early on in the month because every night the sky changes by 4 minutes. And so if you wanted to wait until July 18th, this would be in the glare of the sun because it would be happening an hour sooner. So looking at this image here, what you're looking at is the sickle of Leo here. And if you look at the whole constellation, this is Leo the lion I'm circling. And the back end, this triangle, the star at the end, his name is Denobla, that represents the tail of the lion. And then this bright star here is Regulus, and Regulus represents the heart of the lion. And we have the sickle of Leo here. And what looks like the moon is just, I think, represented in this image a little too bright. That's the planet Venus. So on July 4th, the planet Venus happens to be in the constellation of Leo. But you can see there's a little bit of lightness in the sky. This is facing west. This is 9:30 at night on July 4th, and it's very close to the horizon. Well, to help me explain this 250 light years of America, I have one of our astronomy students and a member of our astronomy club. Simon is a member, and Simon, welcome to the show.
Thank you.
You're welcome. Glad that you could be with us, and you appeared early on in the April show as well, and so that was really kind of neat. And you can see behind us. I typically have a star field of some sort, but you can see behind us, we the people. Basically the Constitution and the shirt I'm wearing, which I do realize I also wore for our June show, but I just thought, how could I not wear this shirt for the July show? So we're combining the concepts of astronomy to the birth of our country, and Simon's going to help explain one of these stars, okay? So as you look here, we have this star, which is like the third. If you start at the end of the sickle of Leo here, 1, 2, 3 stars. This star is Zeta Leonis, or Zeta in the constellation of Leo. So Simon, tell us what are some things that make Zeta Leonis interesting?
Zeta Leonis, also known as Adafira from an Arabic word, is a star about 270 light years away, and it is, from what I recall, blue in color, like many of the stars that we'll be covering. It forms a sort of pair with another star, but it's not quite a binary orbit because the stars are actually really far apart. It just looks like they're right next to each other.
So we sometimes refer to that as a visual binary. They're just kind of lined up, but not gravitationally related.
Yeah.
And about how far away is Zeta Leonis?
Like I said, it's about 270 light years away.
Yep.
And it has a magnitude of 3, which is, which means that it's slightly dim, but still visible to the naked eye during night.
Yep. And as you look at the sickle of Leo, you can easily see it again, as I pointed out for you, the third star over if you start at the end. And if you wanted to count stars starting at Regulus from the bottom up, it's the 4 star. 1, 2, 3, 4. And I have it circled right there. And as Simon said, magnitude 3, 3 1/3. So it's on the dim side, but plenty bright enough to be able to see. And so I would encourage you to go out at the beginning of the month to try to find it, because as the month goes on during July, every night this constellation in the star is going to be moving towards the horizon, and it will be moving out of sight 4 minutes sooner than the night before. So early in the month is a good time to catch that one. Then one of my favorite stars that I like to talk about finding, because I think it's really easy to find, is the star Spica. And Simon's going to share a little bit about that in a moment, but let me show you how to find it. So we have the Big Dipper, and the Big Dipper is close to being in an overhead position. Now, we have moved to July 21st. And the reason for July 21st for these next few slides is that a good friend of mine's birthday is July 21st. But also it gives you a great opportunity as you're looking at the show throughout the month to find it. So what I'm showing you is going to be about an hour sooner if you go back 2 weeks. So this is July 21st that I'm showing you here. And this is about 10 o'clock at night. So 10 o'clock at night, July 21st, looking overhead, you find the Big Dipper. And if you see how the handle of the Big Dipper makes an arc, and we follow that arc to a bright star, a bright reddish-orange star called Arcturus, which is a magnitude 0 star, which is, I think it's about the 5th brightest in the sky. And so we're going to arc to Arcturus and then spike down towards the horizon, spike down to Spica. And that's an easy way to find it. And Simon, tell us a little bit about the star Spica.
Spica is a large star that is about 250 light years away. It is blue, which means that it is extraordinarily hot, and it is actually a binary system comprised of 2 stars that are extremely close together. It also has a magnitude of 1. Its binary system is so close together that we have yet to actually photograph the stars as 2 separate stars. The only way we found out that it was a binary system was by using the Doppler effect, where the faster something goes away from you or towards you, the more it shifts in color. They are also presumed to be egg-shaped due to their own gravity pulling on each other.
Neat. And how far away about is Spica?
Like I said, it's about 250 light years away.
And that is like perfect for our show and what we're talking about, trying to dovetail together astronomical concept of stars and our 250-year anniversary. It's 250 light years away. And I know I've already said this, but it bears repeating. I just think it's so amazing. When you go out during July and you look at that star Spica, easy to find, realize that the photons reaching your eyes left that star when we were declaring our independence. And the Declaration of Independence was being signed. Amazing stuff. Absolutely amazing. So this image here just helps put the context of the star Spica, and perhaps you can tell that Spica is in the constellation of Virgo, the Virgin. And as Simon said, it's a blue star, bluish white in color as you look at it, and it represents a sheaf of wheat in Virgo's left hand. So that's a little bit of the context for the star. Okay? Now, as you look at this slide here, I shared with you how to find Arcturus and how to find the star Spica. And now, as we look towards the south, we see another star right at the bottom of your screen, and this is close to the horizon. It's a star called Antares. And Antares is way beyond 250 years, but I just thought it would be interesting to show it as a color comparison, because Arcturus is reddish-orange in color. It's a magnitude 0. Spica, as Simon said, was and is 1 magnitude. It's a 1.0 magnitude. And Antares is also a magnitude 1 star, but decidedly reddish in color. And so one thing that a lot of people don't take the time to do is to go out and really observe and to note the color difference in stars. Stars do have a color difference. And then in the top left of your screen, you see the star Vega here. And we're going to use that as a reference star because Vega is in an overhead position for most of the summer, and it is very bright. It also is a magnitude 0 on the white side. So I think it's kind of an interesting contrast in color. You have Vega and Arcturus, both approximately the same magnitude, where Vega is decidedly white with maybe a little bluish tint to it. Arcturus is reddish-orange. And then again, Antares and Spica, definitely a nice contrast in color there for you to look at. Then here what we're showing is the summer triangle. And Vega, as I said, is in an overhead position. And you have Deneb, which is at the top of the Northern Cross. If you can make out the Northern Cross here. Deneb is at the top. And then if you add some stars on either side, you get the wings of a swan. So Deneb becomes the tail of the swan. The star Alberio is the head of the swan. And then Vega and Altair are the 3 stars that make up the summer triangle. And then a constellation that we're going to point out now is it's fun to find. So you see where I have the Northern Cross here, and if you look down where I'm circling, it kind of looks like a kite. Well, that's actually a dolphin. That's Delphinus, the dolphin. And we're going to look at a star. Simon's going to share a little bit about the star Alpha Delphinus. Now, typically, the Greek alphabet, alpha, beta, gamma, delta, epsilon, zeta, etc., typically the order of the Greek alphabet as those letters are assigned to stars in a constellation kind of put the order of brightness into play. So the alpha star is typically the brightest star. The beta star is typically the second brightest. Not so with Delphinus the dolphin. Actually, the alpha star, what's called the alpha star, is actually the second brightest star. And it's this star right, just looking at it here, it's this star right here, okay? Right where my red laser dot is. So I'm just going to move it off to the side there so you can find it. And that is the star Alpha Delphinus, which is, as I said, actually the second brightest in that. And it kind of looks like a kite when you look at it, but it's a neat star. And so Simon, please tell us a little bit about Alpha Delphinus.
Alpha Delphinus is about 270 light years as well, like light years away. And like he said, unlike its name, contrary to its name, it's supposed to be brightest based on its name, but it is not. It is second brightest. It is kind of 5 stars if you look at it closely, but these stars have no correlation to each other. And the star that you would see is Alpha Delphinus A. It has a similar pair, not pair, but like similar star, which is binary. It is Alpha Delphinus B. It's far away, not correlated to the primary star. And then there are 4 others that are visibly too close to really make out very well. That's about all I have for it.
Okay,
Yeah.
Awesome. Thank you, Simon. And interestingly enough, if you have a pen and paper and you want to write down the name Nicholas and then spell it backwards, take Nicholas and write the letters backwards, that's somebody named the star with the name of Nicholas spelled backwards. And I'm not sure I can say it. Check it out. So, neat constellation, neat star that I thought would be great for you to see. And right here, I'm showing you another star in the constellation of Hercules here. So here's Vega. Remember, Vega is in an overhead position. I like to look at Hercules as kind of making this H here. If you go across the top of the H, fairly straight line, you come to this star here, which is very faint. We're in the realm of a magnitude 4.5. It's called Kujam. And so I'll leave you to look this up online to get a more definitive, because it's doubtful you're going to be able to take this from what I'm showing you here and go out and find it. But if you looked it up online, it's called Kujam, Cujam, in the constellation of Hercules, and that's another star that's 250 light years away, which is very cool. All right, so there's some stars for you to look at and for you to go to find. And Simon was a big help in helping us learn some things about these stars that are 250 light years away. And I thought something that might be interesting would be, whereas it's summer and we have the opportunity to look towards the center of our galaxy, that I'll show you a little bit about that. But first, Simon, thank you very much for being on our show today.
Thank you.
And for the month, and thanks for sharing the great information that you did about the stars.
You're welcome. Yeah.
Okay. All right, so we're going to take a moment and change the set and have a look at some stars and constellations, and we're going to find the center of our Milky Way galaxy. Well, I hope you enjoyed that time with Simon. We had a good time talking about stars that are around 250 light years away. And I explained, I know, several times what that all means. You can catch it again at the beginning of the show for a detailed explanation. What I want to do now is take some constellations that are very visible during July. And this is the July 21st. I'm staying with the 21st around 10 o'clock at night. And I thought it would be interesting to point to you the center of our galaxy, where you can be looking right towards the black hole that is 3 to 4 million times the mass of our sun. So off in this direction, there's the moon, and I'm not going to spend a lot of time talking about the moon, so I'll just leave it at that. So can you see the teapot right here? You see, this is like the handle. Here's the base. Here's the lid, there's the knob of the teapot right there, and here's the spout. That's the constellation of Sagittarius, or some of the main stars in the constellation of Sagittarius. And then to the right, we have the Scorpion. We have Antares, the heart of the Scorpion, and you can see how it comes down and you see the tail. Shaula is the name of the tail star. And in Honolulu, it's known as the fishhook. Makes sense. And the claws of the Scorpion go out this way. Interestingly enough, these two stars are the constellation, in the constellation of Libra, the scales. And the top star's name is Zubin Eshamali, and the bottom star is Zubin El-Ganubi. And that means northern claw and southern claw. So originally the claws of the Scorpion came out to these two stars, which are now in a new constellation, relatively new, called Libra. Back to the center of our galaxy. If you look at the spout of the galaxy, you can see the steam coming out. That's actually the Milky Way. And if you look at about as far up as the depth of the spout is, that is where you're looking right towards the center of our galaxy. Let me put in a couple of lines here that may just help define the teapot a little bit. I know you don't have these lines in your night sky, but if you come above the spout, right about here, you're looking right towards the center of our galaxy, where we have a massive black hole, 3 to 4 million times the mass of our sun. Craziness. Now what I'm going to do, just to get back to another star, is to shift. We're facing south. I want to shift so that we're actually facing towards the southeast a little bit, because I wanted to kind of circle back with the dolphin. And so you see here is the dolphin. We talked about the star Altair as one of the stars of the summer triangle. And here's Delphinus, the dolphin. Sagittarius is the centaur Archer, and then Scorpius we talked about. And in between Sagittarius and Scorpio, we have the 13th member of the zodiac. More on that another time off Iucus. But thought it would be interesting. And remember, it is the star that is right here, not the one at the junction of the kite's tail, but this star right there, that is a star that's about 250 light years away, and that is Alpha Delphinus. So I hope that you enjoyed the show. This has been 250 light years of America with Belmont High School. And I hope that you will go out and enjoy looking at the stars that we talked about tonight. It's a fascinating opportunity, the only opportunity you have this summer to look at stars whose photons are hitting your eyes when we were declaring our independence. Hope you enjoyed the show. I'm Dave McDonald for The Sky this month. And don't forget to keep looking